Hey guys, it's Miss Johnson, and today I'm bringing you Unit 9, Note 7, which is division with polynomials. We're going to learn two methods of dividing polynomials today, and the first one being long division. So yesterday we reviewed long division with just numbers, and today we're going to talk about how we use that with polynomials. So here's our process of dividing polynomials, and so you can see there are 5 steps to write down. The first one is to set up the box. And what we mean by the box is, you know, the division box where you have just the box that looks like that. Your divisor, the number that's on the bottom, goes on the outside, and the dividend, the numerator, the top, goes on the inside. After you set up the box, you need to ask yourself what number will multiply to make the divisor look like the dividend. How do I make the divisor look like the dividend? That's kind of what we're doing here. How do I make the outside look like the inside? Once we figure out what that number is, we actually do that multiplication. Multiply that number by all parts of the divisor, and then we're going to subtract them, just like we did with long division. And then we repeat this process until we get to the end of the dividend, and we write our remainders out of the divisor. So again, this process is kind of lengthy and it probably doesn't make a lot of sense when you're just looking at it in words, but we're going to do a few examples. So the first example that I have is x squared minus 3x minus 40 divided by x plus 5. So the reason I can't just split it off like we did in Unit 9, Note 6 is because this is a binomial. I have two terms here. So you can't just split it into 3 fractions where you have 2 terms in the bottom because you're still dividing by 2 terms. That doesn't make any sense. We can't put 2 terms in the bottom of each fraction and then try to combine them. That won't work for us. So here's what we do instead. So with 2 terms being divided, that's what goes on the outside of the box. And then on the inside of the box, we have x squared minus 3x minus 40. So then from there, I need to ask myself, how do I make x look like x squared? What do I need to multiply by so that x looks like x squared? And it's another x. And since it's an x, I'm going to line it up with my like terms. I'm going to put it above the x term that's inside. So x times x, now I multiply. And this is like distribution. This x has to be multiplied by both parts. So I have x times x, which is x squared, and then I have x times 5, which is 5x. And now you can see why I have them lined up, because all of my x terms are going to be in this column, all of my x squareds here, all of my constants there, all of my like terms are going to be lined up in columns. So this is the product after I multiplied by the divisor, or by the divisor, and now I subtract the two. So x squared minus x squared gives me 0. That's nothing, which is what I wanted. That's my goal. The reason I picked x is so that those two would drop out. But now in creating that distribution, I've now given myself a new problem I have to tackle. So I have negative 3 minus 5, which is negative 8x. So there's the new problem that I have to tackle. I can bring down the negative 40 and do it one more time. So x to look like negative 8x, that's my goal. I want to make x look like negative 8x. I need to multiply by negative 8. Then I'm going to distribute that. That negative 8 goes to both parts outside, so negative 8 times x is negative 8x, and negative 8 times 5 is negative 40, and I subtract those two. Now here we've got some double negatives going on. I have negative 8 minus negative 8. Minus a negative is plus a positive, and negative 8 plus 8 is 0. So those two drop out, and I'm left with 0, which was my goal. That should always happen for the first one, because that's why you strategically pick this. And then the second one, negative 40 minus negative 40. Negative 40 minus a negative is plus. Negative 40 plus 40 is 0. So I have no remainder here, which is good. So no remainder, and my quotient, or my answer, or my result, is the x minus 8. Let's try it one more time in number 2. So I have 2x minus 1, that's the outside. And then on the inside, I have this top, 2x squared plus 3x minus 5. So I ask myself, how do I make 2x look like 2x squared? Well, 2 times 1 gives me 2, so I don't need another number, but x times x gives me x squared, so I need an x. And then Since it's an x, I put it above the x term, and now I'm going to distribute those. So those get distributed down. X times 2x is the 2x squared, which was my goal. I want to make those two match so that they'll cancel each other out when I subtract. And then x times -1 is -1x, and I subtract the 2. It helps if you put parentheses around that so that you remember that you're subtracting both parts. You're subtracting this term and that term. A lot of people try to subtract the first term but then add the second. So 2x minus 2x squared minus 2x squared goes away, and that's 0. That was my goal. And then 3, positive 3, minus -1. Minus a negative is plus a positive. So 3 plus 1 is 4x. So that's what I have there, and then I bring down that -5 and try it again. So I need to make 2x look like 4x. What do I multiply 2x by to get to 4x? I need a 2. 2 times 2x, so I distribute those. 2 times 2x gives me 4x, and 2 times -1 gives me -2. And subtract both of them. And once again, we strategically picked the 2 so that those would go away. 4x minus 4x is 0. But -5 minus -2, minus a -2 is plus a positive. -5 plus 2 is -3. So this is my remainder. So my quotient looks like x plus 2 minus 3 over 2x minus 1. So I take my remainder and I write it divided out of the original divisor, which was the 2x minus 1. Just like you would when we did yesterday when we reviewed this. If this were just a number, like I think yesterday it was the 6 out of 12, and then we reduced that to 1/2, you would take the remainder and you'd write it out of whatever you divided by. Okay, so that's where that comes from. All right, so now let's compare long division and synthetic division, because long division is what we just looked at. Synthetic division is what we're going to look at next. And synthetic division takes things and makes things a little bit simpler. This is quite a lengthy, arduous process. It takes a while to get through it. So we're going to try and see if we can make it a little bit simpler by using synthetic division. So I'm going to show you the same question, x squared plus 5x minus 24 divided by x minus 3, and we're going to do it in both methods to see the result. So I take x minus 3 on the outside, x squared plus 5x on minus 24 on the inside. And I ask myself, how do I make x look like x squared? Well, I need an x. And then I distribute. X times x is x squared. X times -3 is -3x. And I subtract the 2. So x squared minus x squared goes away. I did that on purpose. 5 minus -3 plus, so that I have x. -24 and try again. What do I multiply x to get 8? So 8 times those two, 8 times x is 8x, and 8 times -3 is -24. Subtract both of them, 8 minus 8, that drops out. And then -24 minus -24, once again, this is plus a positive. -24 plus 24 is also 0, so there's no remainder here. My quotient is x plus 8. That's my result. Now let's take a look at synthetic. So this is a method that we haven't done yet, but this is how things get a little bit different. In synthetic, I'm going to flip, and instead of like dividing things into the divisor and then subtracting the results, I'm actually going to multiply and add. But before I multiply and add, I need to take this divisor and set it equal to 0. So I take the divisor, I set it equal to 0, and it looks like this. 0 plus 3 equals 3. So now 3 is the number that I'm going to put in the outside of the box. Now the nice thing about synthetic is I'm not worried about the actual variables. I'm just worried about the coefficients. So I list the coefficients behind, 1, 5, and -24. I leave myself enough space to write one number, and then I draw a line. That's what I'm going to add underneath. And I'm also going to put in a little box which tells me that's my remainder. Okay. Then here's the process. The first coefficient just comes down. That's all you need. the next thing you do is you multiply 3 times 1 and you put it up there. So I'm going to multiply that and then I'm going to put it right there. And then I add. 5 plus 3 is 8. I do it again. Multiply. 3 times 8 is 24. Put it up there. And I add. Negative 24 and 24 is 0. And that's my result. Now I have to put the variables back in. So I always start at the very right-hand side and work my way backwards. This is your remainder, which is why we put the little box in so we remind ourselves that we have a remainder. So my remainder here is 0, which is the same remainder I got over there. Then this is my constant, and this is my x term. So I have 1x plus 8 with no remainder. Same result, little bit different process. Now we're going to do lots more examples of synthetic division. It looks tricky, it looks confusing. This whole process is very confusing. Nobody said the end of algebra was going to be easy, so here we go. But synthetic is going to save you some time, and it's going to be a little bit quicker and easier. It's really slick process, so after we do it a few times, I promise you'll get the hang of it. Here's our steps. So for synthetic division, we start by setting the divisor equal to 0, solving, and then putting that in the box. So take the bottom, set it equal to 0, and solve. Then the next thing, we need to list the coefficients behind the box. So we just put those coefficients, including the constant, in order behind the box. The next thing that I do is I drop the first coefficient down. That's the easiest part of it. And then I multiply and add. So I multiply the divisor in the first result, put it under the next coefficient, and oops, I didn't get the rest of that line, and then add the two together. After I do that, I repeat the process until I've gotten to the end of the coefficients, and then if my remainder exists, I write it over the divisor at the end. One little note that I forgot to write here, there may be some division that you have. If you had to divide, if you divided the divisor in the first step, you have to divide that same number out of your result. Okay, so we'll see that in some examples today, and we'll talk about it. Let's take a look at number 5. So use synthetic division to find the quotient. I'm going to start by taking this and setting it equal to 0. X plus 3 equals 0. Subtract the 3. I get x equals negative 3. So negative 3 goes outside in the box, and then I list my coefficients in order. 1, 5, 6. Line, remainder, you're going to add here. Drop 1 down. Multiply and add. So negative 3 times 1 is negative 3. Add the 2, I get a positive 2. Do it again. Negative 3 times 2 is negative 6. Add the 2 and I get a 0. So no remainder, which is nice. And then I write out my result. In my result, that's always your remainder, that's your constant, that's your x term. So I have 1x plus 2, or in other words, just x plus 2. And that's my quotient. There it is. Let's try it again. So number 6, I start with that. X plus 5 equaling 0, subtract the 5. X equals negative 5. So I have negative 5 on the outside, then I list my coefficients, 1, 9, 20. Line, remainder box. First one drops down. Negative 5 times 1 is negative 5. Add the 2, you get 4. Negative 5 times 4 is negative 20. Add the 2, you get 0. Once again, no remainder. So your quotient, that's your remainder, that's your constant, that's your x term. So it's really 1x plus 4, or just x plus 4, because you don't need the 1 in front of the x term. Let's try 7. Now we're up to the third power, but the process is still the same. So x plus 3 equaling 0. That's x equals negative 3. Negative 3 goes outside, and I list my coefficients. So 2, 3, negative 4, and 15. Leave a space, put in your remainder box. First one drops down. So there's my 2. Then I multiply, add, multiply, add, multiply, add. So negative 3 times 2 is negative 6. Add them up. 3 and negative 6 is negative 3. Negative 3 times negative 3 is positive 9. Negative 4 and positive 9 is 5. Negative 3 times 5 is negative 15. 15 and negative 15 is 0. Here's your answer. That's remainder, constant x squared. So I have 2x squared minus 3x plus 5, no remainder. That's my result. Quick spot check that you can take note of. Just to check the way you're writing out your answer, notice that I have an x squared here, and notice that I started with x to the third. The fact that I divided out one x to the third divided by x to the first gives me x squared. I divided out one x, so I should be one less than the original power. The original power was 3, now I'm at 2. So I know I've done that part correctly. Okay, so now let's talk about number 8. So in number 8, I'm going to start by taking this and setting it equal to 0. And this is that extra piece that I just added to the bottom of your steps. So subtract the 1, I get 3x equals negative 1, and then divide by 3. So life gets a little bit trickier here. Negative 1/3. So negative 1/3 is the number that I'm putting inside the box. Ooh, that's going to be fun. Here's the thing that you need to remind yourself of. You divided by 3. You had a 3 coefficient in front. We're going to need to use that at the end. So we're going to have to divide this out at the end. Okay, so we'll come back to that. So now let's list our coefficients. Coefficients here are 9, 9 again, 11, and negative 4. So I drop the 9 down. Now, you can use your calculator to do this, but really it's just negative 1 times 9 divided by 3. But if you want to use your calculator to do this, make sure you put it in parentheses. So what this is negative 9 divided by 3, which is negative 3. So then I add them up. 9 and negative 3 is 6. Negative 1/3 times 6, that's a negative 6 divided by 3, which is negative 2. Add those up and I get a 9. Then negative 1/3 divided by 9, or negative 1/3 times 9, that's negative 9 divided by 3, which is negative 3. Add them up and you get negative 7. So there's your remainder. Now, here is the tricky part. I need to divide this coefficient out of the pieces except for the remainder. Because you're going to write the remainder out of the divisor, you don't actually divide it by the 3. But you're not writing these out of the divisor anymore. You just have these by themselves. So you need to take that factor of 3 out. Because you took that factor of 3 out of your divisor, you also have to take it out of your quotient. So 9 divided by 3 is 3, 6 divided by 3 is 2, 9 divided by 3 is 3. Your remainder is going to stay the same. So here's what my answer looks like. Remainder, constant, x squared. That's 3x squared plus 2x plus 3 minus 7 out of the original divisor. So again, because I'm writing my remainder out of the original divisor, I don't actually divide it by 3 there. But the other ones, I'm not writing it out of the original divisor, and I took a factor of 3 out of my divisor at the beginning. I divided by 3 right here, which means I need to divide by 3 right there. Take a factor out at the beginning, you have to take a factor out at the end to keep them balanced. All right, let's keep going. We're going to try a few more of these and then we're going to do some application questions. So number 9, I start with 5x minus 4 equals 0. Add the 4, that's 5x equals 4, and then divide by 5. There's that division again. There's that coefficient of 5 that tells you you're going to need to divide that out at the end. So you have x equals 4/5 here. So 4/5 is the number that goes outside in the box. And again, you can use your calculator to do these calculations for you. You just have to put parentheses around the 4/5. Negative 35 minus 7. So drop this out, drop this down. That's going to be a 50. 4/5 50. So basically, take 50 divided by 5, you get 10, and 10 times 4 is 40. Add them up. That's 50 again. 4/5 of 50 again is going to be 40. Add them up. Negative 35 plus 40 is 5. 4/5 of 5 is going to be 4. 5 divided by 5 is 1, and then you have 1 times 4, which is just 4. Add them up, and you have a negative 3. So I divided by a coefficient of 5 at the beginning. I have to divide these by a coefficient of 5 at the end. So when I do that, I have a 10, a 1, and my remainder stays the same. So this is remainder, constant, x squared, and my quotient looks like 10x squared plus 10x plus 1 minus 3 out of the original. 5x, what was it, plus 4? Minus 4. There we go. Woo, there's my result. All right, next one, 2x plus 3. So 2x plus 3 gets set equal to 0. That's 2x equals negative 3. That's x equals negative 3 halves. Ooh, tricky. Negative 3 halves goes outside. 2, negative 17, negative 38. 2, negative 17, negative 38. Space to write one number and remainder box. 2 comes down. Then negative 3 halves times 2. That'd be negative 6 halves, which is really just negative 3. Add them up and you get negative 20. Negative 3 halves times negative 20. Well, first of all, you know a negative times negative is going to be positive. Second of all, 20 divided by 2 is 10. And then 10 times 3 gives me 30. So this is 30. Add them up, negative 8. So negative 8 is your remainder. Now you divided by 2 at the beginning, so I have to divide these by 2 at the end. Again, you don't divide the remainder. The remainder just drops down. So 2 divided by 2 is 1. Negative 20 divided by 2 is negative 10, and then negative 8 just comes down. So this is remainder, constant, x term, that's x minus 10 minus 8 over 3x plus 2? 2x plus 3, goodness me. 2x plus 3. There it is. All right. 2 more and then some application questions. Number 11. So number 11, we're going to talk about another little snafu in the mix here that we have to take care of. In number 11, I have 6x to the 4th, 15x to the 3rd, and then I jump to negative 28x. I am missing the x squared. I have to fill in a 0x squared. I have to fill it in with something that carries no weight. I have to have a hole for it. I can't just skip over that term. So I have to fill it in because I'm going to have an x squared in my result. If I don't leave a hole for that, then I lose that x squared term and then I don't have the right result. So if you skip a power, I went from x to the 3rd to x to the 1st. I have to fill it in with x to the 2nd, and that gets a 0 because 0 is what carries no weight. You're basically just filling a hole with nothing. Fill the hole with nothing. Nothing in math means 0. Now the rest is the same. X plus 2 equals 0. That's x equals negative 2. No division here. Coefficient is 1, so that makes life a little bit easier. So I have an outside number of negative 2. Then my coefficients look like this. 6, 15. I plug in that 0 for the x squared. Negative 28, negative 6. Draw a line. Put in your remainder box. So the 6 comes down. Negative 2 times 6 is negative 12. Add those up, you get 3. Negative 2 times 3 is negative 6. Add those up, you get negative 6. Negative 2 times negative 6 is positive 12. And negative 28 plus 12 gives me 16. Negative 2 times 16 is negative 32. Add those up and I get negative 38. So I have a remainder here of negative 38, which is kind of a funny remainder, but that's okay. So this is remainder, that's my constant, that's my x term, that's my x squared term, and that's my x to the third term. So I start at the end and I work my way to the beginning. So 6x to the third plus 3x squared minus 6x plus 16 minus 38 over original divisor, x plus 2. One more just basic one. So now we need to know, now we know that we need to check our powers. So I have x to the fifth, I'm missing x to the fourth. Then I have x to the third, x squared, x to the first constant. So everything else is fine. This is x minus 3 equals 0. Add the 3, and I get x equals 3. So 3 goes outside. Coefficients are 2, negative 1, 3, negative 2, and oh, see, and I just did it myself. I skipped the 0. Get rid of that, sorry. 2, 0, then negative 1, then 3, then negative 2, then 7. Can't skip a hole. Okay, 2 comes down. So I have 2, then 3 times 2 is 6, add them up, you get 6. 3 times 6 is 18, add them up, and you get 17. Then 3 times 17, so 3 times 17 gives me 51. So I have a 51 up here. I'm getting some really big numbers here. So then that's 54 as a result. 3 times 54 gives me 162. Holy buckets, that's 160 as a result when I add them up. And then 3 times 160 is 480, keeps getting bigger, 487 as a result. So you can end up with a bigger, and that's okay. That doesn't mean you've done it wrong. That just means that we've got some. I didn't divide anything out at the beginning, so that's good. That's just my result. That's the remainder. That's constant, x squared, x to the third, x to the fourth. I started with x to the fifth. I end with x to the fourth, so I'm in good shape. So 2x to the fourth plus 6x to the third plus 17x squared plus 54x plus 160 plus the 487 out of the x minus 3. Goodness, that is a long result. All right, so let's take a look at some application questions and then we'll be all set. Number 30, it says the area of a rectangle is x plus 3x plus 4x plus 3x plus 4x plus 1 squared inches. The width of the rectangle is x plus 1. What is the length of the rectangle? So I'm told area of a rectangle. I know that area is length times width. I know the area, I know the width. My question is the length. If I want length by itself, I need to divide it by the width. So I'm going to take area, I'm going to divide it by the width to get length, which is what I want. So I need to take this and I need to divide it by that. Well, I'm going to use synthetic division because I think synthetic is a little bit easier to work with. So x plus 1, set that equal to 0, that's x equals negative 1. Then list your coefficients. My coefficients here are 1, 3, 4, and 1. I don't skip any powers, so that's good. Draw a line, put in a remainder. I don't have to fill in any holes. Drop the 1. Negative 1 times 1 is negative 1. Add them up, I get a 2. Negative 1 times 2 is negative 2. Add them up, I get a 2 again. Negative 1 times 2 again is negative 2. Add those up and I get a negative 1. So that's remainder, constant, x squared. I have 1x squared plus 2x plus 2 minus 1 out of the x plus 1, which is my original divisor. This is a technical length, so I'm looking at inches on my label, and there's my result. One more application. The area of a triangular sail is 16x to the fourth minus 60x to the third minus 28x squared plus 50x minus 32 square meters. My sail is x minus 4 meters. What is the length of the base? So you are told the area, you're told it's a triangle because it's a sail on a sailboat, and you're told the height, you're looking for the base. So if you think back to your knowledge about the area of triangles, you know that you're looking at area equals base times height divided by 2. You're trying to find the base. That's your goal. If I want to get the base, that means I need to multiply by 2 to cancel that. So I base question. That's what I'm trying to find. So the reason I bring that up is because you need to actually take your area and you need to double it because of that power or that factor of 2 there. So I'm going to multiply my area by 2, distributed 2 all the way through, and I end up with 32x to the 4th minus 120x to the 3rd minus 56x squared plus 112x minus 64. That's the number that I have to divide. I'm dividing by x minus 4 equaling 0, x equals 4. So 4 goes on the outside. My coefficients are these: negative 120, negative 56, 112, negative 64. I drop that down, 32. 4 times 32 gives me 128. Add them up, and I'm at positive 8. 4 times 8 gives me 32. Add them up, and I'm at negative 24. 4 times negative 24 is negative 96. Add them up, and that's 16. And 4 times 16 is positive 64. Add them up and check that out. No remainder. So I have my remainder here, which is nothing, constant x squared, and x to the 3rd. That's 32x to the 3rd plus 8x squared minus 24x plus 16. And my length here is meters. Holy buckets. Synthetic division, long and synthetic division. That is our last notes video of this entire course. So congratulations on making it to the end. And come see me if you have questions. Thanks for listening.